Hi, I'm Joe, and welcome to my YouTube channel. Or if you're a returning viewer, what's wrong with you? But thank you, and you're my friend now. Last week we left off watching the village idiot interacting with the robot. It's always so fascinating to watch two primitive creatures meet for the first time. It seems this is the beginning of a strange mating dance. Or perhaps they're preparing to fight. It's very hard to tell. This demo is on the simplest level. There's a small webcam perched on top of the robot, and it's looking upward at about a 30-degree angle. The code is simple. The machine vision finds my face, and it moves the robot to keep me centered in the camera's image. But this is far from autonomy. The question now is, what comes next? Well, I concluded at a high level it needs to have spatial awareness, knowing what's around it. I explored every option I could think of for appropriate sensors, and finally landed on LiDAR. LiDAR is a time-of-flight sensor, meaning it releases a pulse of energy, in this case light, and it times how long it takes for the energy pulse to travel to a blocking object and be reflected back. This is how echolocation works for bats. My first thought was to use 3D LiDAR, like you see on these new robot dogs or self-driving cars. But the price tag was a bit out of reach, so I tried to figure out how to make a two-dimensional LiDAR do the job. Many robot vacuums use these to great success, seeing the world like an old-fashioned radar screen. This is just fine for a dust-eating pancake, but my robot is tall. Not super tall. My target height will be about 36 inches, which is just shy of 1 meter. But tall enough to see on top of most kitchen countertops. Now this literally adds a new dimension to the robot's understanding of its environment. Using a two-dimensional LiDAR, if it's placed at floor level, it will detect anything the robot can't drive over. But what about driving under? Tables pose a serious challenge here. My next plan of action was to place a LiDAR on top of the robot with a downward angle, allowing it to scan the environment in front of it as it goes. This proved clumsy and difficult to achieve without a super reliable method for knowing exactly the distance traveled and in what direction. I also would like the robot to know the distance of objects identified by the machine vision. What I really needed was a camera where every pixel was a time-of-flight sensor. Was such a thing out there? Yep, there sure was. Many quite expensive, but soon I found Arducam's TOF camera. It was perfect. This camera returns an image where each pixel represents a distance to the object. First I tried it out with the Jetson, but at that time the drivers didn't play nicely with the new Jetpack 6.0 version of the operating system. So, knowing I needed some extra computing power anyway, I acquired a Raspberry Pi 4B and set it up with the time-of-flight camera. This was exactly what I needed. But having the camera itself wasn't enough. To really use the data, I needed the camera's direction and angle, so it needed to be attached to a frame with an IMU, or inertial measurement unit, to give me that data. So I needed to build a head. As I worked on the high-level design of my system, I found that I could indeed contain all of the computing power needed for this robot in the skull itself. And thus began this poor soul's journey down yet another path he had seldom walked, computer-aided design, or CAD. My brother has a 3D printer, so it made sense to take advantage of this technology to create some of the intricate parts I would need. But the last time I had used CAD software was in college, and that was mostly just tinkering. I watched a few YouTube videos on several pieces of software and decided to try Shaper 3D. They boast that you would be modeling things within 15 minutes of installing the program. Hold my beer. But they seem to be right, even with my infantile knowledge of such work. I tried a few things, then got frustrated, then tried again, and finally made my first part. It was a tray to mount the cameras and computing hardware. With my new part in hand, after a couple of reprints because I needed to adjust it, I quickly soldered up a board for the inertial measurement unit and mounted all the electronics in the tray. And next was the skull. After a long and sadly doomed attempt, my brother told me that I was thinking about it wrong. I was thinking in terms of a 3D part, when I needed to be thinking in terms of 2D plans that turn into a 3D part. This may not make sense to you, but to this numbskull it was exactly what I needed. Armed with his new perspective, I started once again. And after a long evening working on the model, I had something ready to print. And I think it came out lovely. I'll have to adjust it in the future, but for now, it'll work. I made the face in the same fashion. I think it'll take another iteration before I want to move on, but I like where it's going, except that it looks suspicious of me. But with that, I assembled the head, and got my first look into the face of my creation, and I'm pretty sure it was judging me. And that's where we leave off this week. I have a long way to go, but until next time, please like and subscribe, and perhaps drop a comment about features you think a household robot should have, or even say hi. I like that too. Thank you, and stay hydrated.